Hey everyone, so here we are again. We're almost done with radicals, so we'll be moving on to something else soon, but there's a couple more things that I want to show you. So today we're going to be solving equations that have rational exponents in them. So you will need your note sheet, your worksheet, and your calculator. So let's get to it. All right, let me set this down. Okay, so the steps that you're going to follow are at the top of the page, and of course I'm going to follow those and explain everything as I go, just as always. So for number one, our equation is 2x to the 3/2 power is equal to 250. So the goal, first of all, is to get the x that is raised to a power by itself. So we want just this part to be by itself. So the 2 is not part of that. So we want to eliminate the 2 right now. So I'm going to begin by dividing both sides by 2. That will cancel those 2's, of course. So I'll have x to the 3/2 power, and then 250 divided by 2 is 125. Okay, so now we're going to eliminate the exponent. So the way it works is that you look at your exponent, which is a fraction, and you want to think of its reciprocal. So the reciprocal of 3/2 would be 2/3. So you're going to raise both sides to the 2/3 power. Now, when we studied exponents a while back, we learned that whenever you have a power raised to another power, you would multiply the powers. So if you were to multiply 3/2 by 2/3, that would be 1. They would cancel each other out. So you'd have x to the first power, or just x. Now on the right side, just recently, we've learned that any exponent that is a fraction can be rewritten as a radical. So that's what I'm going to do next. So the 3 in the denominator makes it a cube root. The number 125 goes inside, and then the numerator, the 2, becomes the power inside of the radical. So you will have cube root of 125 squared. Now you'll notice it mentions in the notes that if this number is even, you would use plus or minus. But because that's an odd number, no plus or minus is needed. So we just need to figure out what this is. So let's go to our calculator and see what happens. All right, so we're gonna go to math and choose cube root number 4 and put 125 squared inside and press enter. So you should get the answer 25. Okay, so now we have to check our solutions. This is kind of like the last lesson in that sometimes when you plug the number back in, it does not give you the number it needs to be. So we're going to go back to the original equation and plug in 25 for x. Okay, so the original equation had a 2. Now in place of the x, we're going to put in 25. Put 25 in parentheses, like that. And then we're raising it to the power of 3/2. Now, if your calculator is like mine in that it has the raised box, you can just type in 3/2 and it will be fine. But some of you don't have the exact same calculator, so you might have to put the 3/2 in parentheses. So if you don't have the raised box, that's probably what you need to do, is put 3/2 in a separate parentheses. But what you should be getting when you do that is 250. So if your calculator is not giving you 250, try putting 3/2 in parentheses. Okay, so if you notice, the problem was supposed to be 250, so that means our answer 25 is good. Okay, so we'll come back here. This is where we left off, so x will be 25, and we've already checked it, so number 1 is finished. Final answer for number 1 is 25. Okay, so for number 2, we have 3x to the 4/3 power equals 243. So this is similar to the last one in that we want to get the x raised to the power by itself. So we don't want the 3 to be there. So I'm going to divide both sides by 3. That will cancel those 3's. So then I'll have x to the 4/3 power equals, and if you do 243 divided by 3, you'll find that to be 81. Now we want to eliminate the power that is a fraction. So you use its reciprocal. So the reciprocal of 4/3 would be 3/4. So we're going to raise both sides to the 3/4 power. Okay, so on the left side, the 4/3 and the 3/4 cancel because you would multiply and it would be 1. On the right side, we're going to change this to a radical. So the denominator 4 would mean it's a 4th root. The 81 would go inside of the root, and the 3 means it's 81 cubed. Now in the notes it mentions plus and minus, and this would be a time to use it. So because the 4 is even, that means we'll include plus or minus when we give our answer. So we're going to need to see what plus or minus the 4th root of 81 cubed is. Sorry, not right there. In the answer, we'll put plus or minus. Okay, was on the wrong step. So don't put plus or minus here, but in your answer we will. Okay, so now I'm going back to the calculator to figure out what the 4th root of 81 cubed is. Okay, so back over here. Now 4th root we talked about a while ago, but it may be a little different than my calculator if you have a slightly different version. So if I go to math, and it would be option number 5 where there's an X over in the corner. I'm going to pick that. Now when I do that, I get a block where I can fill in a number in the corner. So I would put the 4 there and then use the right arrow to get inside of the radical. And then our number is 81 cubed. So I'll put 81, oops, I messed that up. Back up, delete, not 88, 81, to the 3rd power. So the answer you should be getting is 27. Okay, so if your calculator is a little different than mine, you might have to put the 4 in first, then go to the math screen to pick the radical, and then put the number inside. So play around with your calculator a little bit and see if you can get 27, because that's what it should be. Now if you look at the note sheet, remember we put plus or minus on this one, so it should be plus or minus 27. But we would have to check our calculator with our calculator to see if it's actually right. We want to see if both of them are right. Okay, so go to the original equation and we're going to plug in 27. So put the 3 in. You'll need to put the 81 in parentheses. Nope, not 81, sorry. Our answer was 27. I was looking at the previous step. All right, so back that up. Sorry about that, I'm putting in 27. Okay, so put 27 in parentheses, raise it to the power of 4/3. And on my calculator, I'm able to just keep the 4/3 like that. You might have to put 4/3 in parentheses on your calculator. You just have to check it out and see. But what you should be getting is 243. So notice that is the number it was supposed to be. Okay, but we also said that negative 27 would be a possible solution, so try that as well. Repeat the same thing, but put in negative 27 instead. So put in negative 27, also raise to the 4/3 power. And notice that that also is the exact same thing, 243. So that means both of the solutions, positive and negative 27, work. So I'm going back to the whiteboard. So in your answer, you would put plus or minus, and then we said it was 27. And we've already checked both solutions on the calculator and they were both fine. So this one has 2 solutions. Now the reason why we had plus or minus again is because the root was even back here. And in the previous one, number 1, the root was odd, so we did not. So that's the rule you have to remember. Even roots need plus or minus, and odd roots do not. Okay, so number 3, we have 2x to the 1/4 power plus 5 equals 13. Okay, so we're going to have to do a little bit of rearranging because we want the x to the 1/4 power to be by itself. So I am going to subtract 5 first. That will get rid of the 5, so it'll be 2x to the 1/4 power. 13 minus 5 would be 8. I also want to eliminate the 2, so I'm going to divide by 2, which will eliminate those. And I'll have x to the 1/4 power equals 8 divided by 4, or 2 is 4. Okay, so now we're at the point of raising to a power. So whatever fraction you have, think of its reciprocal. So the reciprocal of 1/4 would be 4. So we're going to be raising both sides to the 4th power. So on the left side, the 1/4 and the 4 will cancel, just leaving x. And on the right side, this is not a fraction. This is just the number 4. So you don't need a radical. You would just need to figure out what 4 raised to the 4th is on your calculator. So no radical this time. Okay, so if we do 4 to the 4th power, we get the answer 256. And we just need to see if we plug in 256, would we get the same, or get the answer we need. So let's try it. So go back to the original equation 2, put the answer 256 in parentheses, raise that to the power of 1/4, and some of you might need 1/4 in parentheses, depending on your calculator. I'm going to need to press the right arrow on mine to get it out of the exponent, and then I'll put plus 5. No, yes, plus 5, that's right. So some of you that needed to put the exponent in parentheses, you would need to close off the parentheses before you put plus 5. And let's see what we get. It's 13. So yes, that's what we wanted it to be. It's 13. So that means our answer, 256, is good. Okay, so final answer for number 3 is 256, and we've already checked it. Now, we did not put plus or minus on this one because we did not have a radical. So the radical would mean the possibility of plus or minus is there, but not this time because that 4 was not a fraction. So 256 would be it. Okay, so number 4, we have x plus 7 to the 1/2 power equals x minus 5. Now this time there's nothing to rearrange because of the parentheses. That means all of this is raised to the 1/2 power. So we're going to go right to the step of raising to a power. So you think, what is the reciprocal of a 1/2? And that would be 2. So we're going to square both sides of the equation. On the left side, the 1/2 and the 2 will cancel because they would multiply to make 1. So it would be x plus 7 on that side. Now on the right side, we talked about this in the last video. Whenever you have something squared, think of it as multiplied by itself. So we'll think, what is x minus 5 times x minus 5? So you would need to do FOIL on the right side. So first would be x squared. The outside would be negative 5x. The inside is another negative 5x. And the last would be positive 25. Then we would combine those negative 5's in the middle, so it would be x squared minus 10x plus 25. Now this is a quadratic equation because the x is squared, so I'm going to need a 0 on one side in order to solve. So I'm going to get a 0 on this side. So I'm going to subtract the x and also subtract the 7. So it's okay if the 0 is on the left side, that's perfectly okay. And on the right side, I would have x squared, of course. If you add negative 10x with negative x, that would be negative 11x. And then 25 and negative 7 would be 18. So just like in the last lesson, at this point, you would factor that. So you're looking for what factors of 18 add up to negative 11. And both numbers would have to be negative for that to work. So it would be negative 9 and negative 2. And after you set those equal to 0, you would get x equals 9 and x equals 2. Okay, but we have to check these on our calculator. So let me go back to the calculator and check them individually. Like check 9 first and then check 2. Okay, so the number that you're putting in for x is 9. Let's try that one. And we need parentheses, it shows. In the original equation, there were parentheses. So it would be 9 plus 2 raised to the power of, I just got an email, gotta close it out. Okay, so 9 plus 2 to the half power. Okay, and press enter. Oops, not 22, gotta delete that. Okay, enter. Now the original problem was x plus 7. That's why it didn't work. Sorry about that. I was looking at the wrong thing. So it should have been the number 9 plus 7. Was looking at the wrong problem. Okay, so 9 plus 7 raised to the half power is 4. Okay, so we want to see if we would get the same number on the other side. So if you did 9 minus 5, of course, that's 4. So remember, the goal is to get the same number on both sides of the equation, which we did. Okay, so 9 is perfectly fine. So now we're going to try 2. So this time I'm going to do 2 plus 7 raised to the half power is 3. And on the other side, if I were to put in 2 minus 5, it would be negative 3. So those two numbers are not the same. 3 and negative 3 do not equal each other. So that means that number 2 is no good. It would be called an extraneous solution. Okay, so back to the whiteboard. Here we go. So remember, our options were 9 and 2. When we tried 9, we got the same number on both sides, but when we tried 2, we did not. So 9 works, 2 does not. Okay, just a couple more. So on number 5, we have 7 minus x to the half power equals 2x plus 13 to the half power. Okay. So you don't need to move anything around. We would go right to the step of raising to a power. So you think, what is the reciprocal of a half? That would be 2. So I'm going to square both sides. And when you multiply a half times 2, you get 1. So that means you just have 7 minus x on one side and 2x plus 13 on the other. So this is a linear equation. There's no squared in it, so you don't have to factor anything. We just need to get all the x's on one side. So for instance, I could add x over here. That would eliminate that. We would still have 7. 2x plus x would be 3x, and there's still 13. So then we would subtract the 13 over. 7 minus 13 is negative 6 equals 3x. And then divide by 3. So negative 6 divided by 3 is, of course, negative 2. Okay. But we want to see if negative 2 would work if we plug it into our calculator. Okay, so in the original problem, there were parentheses, so use them. So it would be 7 minus negative 2. Now be careful here. There was a minus in the problem, and then we're plugging in -2. So it's gonna look like a double negative like that. And then I'm raising it to the half power, and enter. Okay, so that time I got 3. So I want to know if I would get the same thing on the other side. So remember, use parentheses. So 2 times -2 plus 13. And also raise that to the half power. And it's also 3. So because we got the same number twice, that means our answer is good. So -2 works. Final answer for number 5. Alrighty, so number 6, we have 2x plus 1 raised to the half power is -5. Okay. So you don't need to move anything around, just go to the step of raising to a power. So the reciprocal of 1/2 is 2, so I would square both sides. On the left side, the half and the 2 would become 1, so it's just 2x plus 1. On the right side, if you do -5 squared in parentheses, like it should be 25. -5 times -5 is positive 25. If you use a calculator for that, the parentheses are necessary. Okay, so this is just a linear equation to solve. I'm going to subtract 1. 2x will be 24, divide by 2, and we get x is 12. Okay, so that was a fairly easy one to solve, but we want to know, does 12 actually work when we plug it back in? So let's go. Plug in 12 and we're done for the day. Okay, so the original problem had parentheses, so use them. And then you got 2 times 12 plus 1 is 25. Oh, I forgot to do the half power. Oh, dang it. Okay. Yeah. So 2 times 12 plus 1 raised to the power this time, 1/2 is 5. Now, if you look in the original equation, the other side is -5. So 5 and -5 are not the same thing. So that means our solution, 12, is no good. So this is important. We plugged in 12 and we did not get -5. So that means that 12 is no good. Now there is not a second equation, or second solution I should say, to check. So that means there's nothing else. So when this happens, you would write down that there is no solution to this equation. So that can happen sometimes. When it doesn't work and you plug it back in, it's no solution. All right, y'all. Hope you're having a great day, and I'll see you next time. Miss you. Bye-bye.